Hello guys, and welcome back to another episode of chemistry. And of course today we're going to continue our study of chemical energetics. I'm going to look at activation energy. In the previous episode we looked at what enthalpy. Today now we're going to look at what activation energy. All right, do not forget that this tutorial of course is brought to you by the one and only O3 School JAMB app. It is a CBT practice app and your exam is a JAMB CBT exam. It's a CBT exam. So you need a very good JAMB CBT practice app like the O3 School JAMB app to succeed in your JAMB CBT exam. Okay, there's nothing more to talk about. All right, the app has all the past questions you need for all subjects inside one application. That is one. Okay, that means you do not need to go and carry 1,500 naira to be buying one past question. One past question each for your 4 subjects. That means it will make you to spend 6,000 naira. All right. So some of you will be proving that you are wise, and then in the tail end you see that what, man, you are not wise. All right. So please, this application has all you need to succeed in the exam. Before the end of this class, I'm going to tell you more about the application. But for now, it is good that you know that what you need to get the application on your phone. Download it immediately. All right, do not forget to like this video. Don't forget to subscribe as you are watching right now. Please do it. Okay, you can take one moment now and just click on that like button, click on that subscribe button, and keep sharing our videos. All right, so please let us head to the board and let's talk about what activation energy. All right, so activation energy in chemistry is what we call the energy barrier that must be overcome. Okay, it's an energy barrier that must be overcome. Okay, before what a reaction can take place. Okay, we call what activation energy the energy barrier that can be overcome, that must be overcome by colliding particles before they can form what products. Okay, so if you have a reaction like A plus B equal to U C plus D, okay, there's a minimum amount of energy, okay, that's required by this reactant in this reaction, okay, before they will form what products. There's a minimum what amount of energy that's required. Okay, so we call what activation energy the energy barrier that must be overcome by colliding with particles before they form products. And then bring it out so that it becomes very clear for us to understand. We say what activation energy is the energy barrier that must be overcome by colliding particles before they can form what products. So before they can form what products, they must first of all overcome this energy barrier that I'm talking about. They must first of all overcome this energy barrier before what they can form the product. Okay, and usually when particles collide before a reaction, okay, before the reaction takes place, when the particles come together, or when they collide before the reaction, okay, the particles usually acquire kinetic energy. Okay, that kinetic energy usually increases. You know what kinetic energy is, right? Energy due to a body in motion, possessed by a body due to its motion, due to motion. All right. So now, when particles collide before a reaction, their kinetic energy usually increase, right, until it is sufficient enough to drive those colliding particles into a reaction or particle formation. Okay, so you must get it clear. I'm trying to drive a point home. Okay, I'm saying that when particles collide, before the reaction actually takes place, when they collide, okay, you see that their kinetic energy usually increase until it is sufficient enough, until it is sufficient enough to drive them into a reaction. To drive them into a successful reaction and particle formation. Okay, this Ke usually goes up, it increases. Once it has gotten the minimum amount of energy, then the reaction can proceed. Okay, so this is what we call I'm trying to explain why this activation energy is what is needed in reactions for them to take place. Okay, so now let us use an example. Let us compare this to what? Let's say some of you, I'm sure that you have stayed in a fenced compound before. Maybe the children on the other side are playing football. During their process of playing the football, they mistakenly will kick the ball over to your own side of the fence. Okay, so let us compare this now to you now trying to watch throw the ball back to the children on the other side. So you now you have the ball has come to your side. You need to throw the ball to the other side. So you want to overcome that steep barrier. All right. So sometimes have you not tried to throw something over a fence and you see that the thing comes back to you? Have you not tried? I'm sure you have tried that before. Okay. So if you pick that ball now and want to throw it back to the children, all right. If you throw it, okay, there's a minimum amount of energy that you need. There's a minimum amount of energy that you need for the ball to go over the fence. Or if you want to bring it back to chemistry, for reactants to become what product, there's a minimum amount of energy required by reactants, okay, to become what products. Okay, that minimum amount of energy is what we are calling the activation energy. So for you now that is about to throw the ball, okay, when you throw the ball, all right, and it goes over, that means what you were able to generate enough of energy to throw the ball over the fence. Will you just stay like this and do like this? No. Sometimes you see you do like this, you raise you carry the ball, push it over, okay, to jump over the barrier, to jump over the fence so that it will go over to the other side. Now, this is what we call the activation energy. You need that the minimum amount of energy, the minimum energy required by reactants in a reaction, before they become products is called the activation energy. Okay, so all reactions will require this activation energy. Okay, the minimum amount of energy, the minimum energy required by reactants in a reaction before they can become product. So that is called the activation energy. Now let us go back to using our comparison of throwing the ball over the steep barrier or throwing the ball over the fence. Okay, now if the energy you generated is not sufficient enough, okay, that's why sometimes when you throw something over, I want to try to throw something over the fence, sometimes to come back to you. That means you did not generate enough energy, right? So you carry the thing again, you press it, you say this time, go. You throw it again. Okay, so when the energy that you generated is not sufficient, the ball will fall back to its original position. Okay, that means the reaction will not go through, it will not occur. Okay, when the minimum amount of energy, when the activation energy has not been reached, the reaction will not proceed. Okay, it will not occur. Okay, you must take note of that. We're going to see them in past questions now. All right, so that's why I say you must get the UTME School JAMB app. It has all the past questions that you need for all your subjects, all of them inside one application. Okay, so please get that app immediately. All right, so now, as I'm saying, when the energy you generated is not sufficient, the ball will come back to you. Okay, it will fall back to its original position. But when the energy you generated is sufficient, you see that the ball will cross over to the other side. All right, so that means that the reactants will become product. That means that the reaction will occur. Okay, if the minimum amount of energy, if the activation energy, if the activation energy is of the reaction is what is reached, okay, the reaction will occur. But if you do not reach the activation energy, the reaction will not occur. You must generate that minimum amount of energy. You must generate that amount of energy before reactant can work and become product. All right. So it is very, very important that we take note of this. Now, another thing I want to quickly throw a light on is the heat content, delta H. Okay, so when delta H is measured, when we measure in the last class we talk about enthalpy change, right? So we want to just throw something about it here also. So now when delta H is measured under standard conditions, the standard condition here we're talking about is what is temperature. Temperature like at room temperature, that is 25 degrees Celsius or 298 Kelvin. Okay, this is standard temperature, 25 degrees Celsius room temperature or 298 Kelvin. Okay, standard concentration. Okay, that's 1 mole per dm cube. Okay, for reactions involving aqueous solutions. For reactions involving aqueous solutions. Okay, and pressure is 1 atm, 1 atmospheric pressure, which is 760 millimeter mercury. Okay, for reaction, or it's same thing as what 1.01 times 10 to the power minus what 5 Newton meter square. Newton meter square. Okay, that is what standard pressure. Standard temperature 25 degrees Celsius or 298 Kelvin. Concentration 1 mole per dm³ for reactions involving aqueous solutions, and pressure 1 atm, that is 760 milliliter mercury, or in Newton meter square. This is same thing as 1.01 times 10 to the power minus 5 Newton meter square. Okay, for reactions, this one is for reaction involving gases. Okay, so now when delta H, when the heat content is measured, okay, when the energy change, okay, when the heat content is what is measured under the standard condition, we do not call it what this again. We call it what standard heat of what of reaction. Okay, we call it the standard. We call it standard heat of reaction. Okay, and we do not call it delta H again. We call it delta H naught. Delta H naught, which is called standard heat of reaction. Okay, so when delta H is measured under standard condition, that is the standard condition, okay, we call it what the standard heat of what of reaction. Standard heat of what of reaction. You must take note of that. All right, now lastly, before we take questions from the O3 School JAMB app, okay, please like this video, subscribe, and what keep sharing. All right, and of course, please the app, like I said, let me talk about the app now before we continue, before we talk about the last part. All right, so it's very important to know that what the app has some other wonderful features. Like, of course, we have what the classroom feature. That classroom feature has lecture notes. It has your textbook. You don't need to go and buy textbook again. So that means you can study on the app offline. Okay, study on the app, and then you can take tests after you study a particular topic, right? Aside from that, there's a question search feature. All right, that question search feature enables you to search for question according to topic, so that the question that has been said under that particular topic will come out for you to answer. Isn't that not good? Then we have the UTME challenge. This one is the best feature of the app because you have to put yourself in that competitive mode. Okay, so the UTME challenge is a challenge that will conduct every Saturday till 1 week to your main JAMB exam. Okay, it's a mock challenge, so you are competing with your mates. You are winning prizes. We are getting used to how JAMB said that question, okay? And you are seeing your results released every week. So if you are seeing your results released every week, that means you can be able to track how prepared you are, isn't it? So that is also there. And then you are able to build your confidence with the main exam. All these features, all the past questions plus all these features I mentioned is just for 3,000 naira one-time payment. As at the time of shooting, it will increase later. So please, focus on passing your exam at once. It will increase, the price will increase. So focus on passing your exam at once. All right. So please get the app. To activate, just click on activate after you have downloaded. At the top, you see buy activation key. And then, of course, you can see what the 3 options for payment. You can use your ATM card to pay online, your debit card. Then you can also transfer to the O3 Schools app account or use Google Pay to pay. All right. Now let's continue to the last part. Now, the last thing I want to tell you here is that for reversible reactions, in which the rate or in which the forward and the backward reactions are occurring under the same condition. For reversible reactions, okay, for reversible reactions in which the forward and the backward reactions are occurring under the same condition, it is very important to note that that the energy change for the forward reaction is equal in magnitude, but opposite in sign. But opposite in sign, right? But opposite in sign to the backward reaction. Now let me go over that again. I said for a reversible reaction in which the forward and the backward reaction are occurring under the same condition. All right, what I'm saying is that the energy change for the forward reaction, okay, is equal in magnitude but opposite in sign to the energy change for the backward reaction. What I mean is that if, for example, the energy change for the forward reaction is, let's say, minus 250 kilojoule per mole. Okay, if, for example, the energy change for the forward reaction is minus 250 kilojoule per mole, that means the energy change for the backward reaction will be plus 250 kilojoule per mole. Okay, please take note of that. So I'll go over that again. I said for a reversible reaction with the forward and the backward reactions are occurring under the same condition. Okay, what I've said is that the energy change for the forward reaction is equal in magnitude but opposite in side. But opposite in sign to the energy change for the backward reaction. Is that clear? All right. So what I'm saying is that, for example, that if the energy change for the forward reaction is minus 250 kilojoule per mole, the energy change for the backward reaction will be plus 250 kilojoule per mole. You can see they have the same magnitude, but the sign is different. But they have a different sign. Okay, please take note of that. Now let's quickly see, before we round up this class, let's see examples of exothermic reactions and endothermic reactions. All right. So in the last class we talked about exothermic and endothermic reactions. So we're still talking about chemical energetics. So that we do not miss anything, let's just quickly add this. Okay, it's important to know that examples. Let's see endothermic reaction. Example of endothermic reaction is the thermal decomposition of calcium carbonate. Okay, this is calcium tricarbonate 4, right? Okay, that's CaCO3. This is an example of an endothermic reaction. Another example is what thermal dissociation of ammonium chloride. Okay, this is another example of an endothermic reaction. If you see this one is thermal decomposition, this one is thermal dissociation. We have done what types of reaction before. Okay, so all types of reaction we have taught them in this channel. So there's no way in this world I'm going to tell you what thermal decomposition or what thermal dissociation is, or what the difference between the two are, because we have everything in this channel. So it's now left for you to go and study it. All right, so now let's quickly see an example of exothermic reaction. Exothermic reaction. An example of exothermic reaction, of course, is the reaction between an acid and base. Okay, a reaction between acid and base. One we call neutralization reaction. Okay, so that's an example of an exothermic reaction. Okay, another example of exothermic reaction is the reaction between hydrogen and nitrogen to form ammonia. Okay, this is another example of an exothermic reaction. All right, so these examples are okay. Example of endothermic: thermal decomposition of calcium tricarbonate 4, CaCO3, thermal dissociation of ammonium chloride. The example of exothermic reaction is reaction between an acid and a base, that is a neutralization reaction, and the reaction between hydrogen and nitrogen to form ammonia. Okay, so now quickly I'm going to go to the O3 School JAMB app and take questions to cement our understanding about what we have just done. Okay, so if your hands are not busy, let me get my application. All right, so I have my application on my phone here. All right, so let's see the questions. Okay, all right, so this is a 2017 question. Okay, number 13, 2017, number 13. Okay, they say the minimum amount of energy that colliding molecules must reach to possess for their collision to be successful, okay, is known as what? A, they say thermal energy. Is it? No. B, they say collision energy. C, activation energy. D, kinetic energy. And the correct answer there without being told, okay? Even if you be wary, you will know that the answer there is what? Of course, that it is activation energy. So our correct answer there will be option C. Now, this is a 2015 question number 10. 2015 question number 10. They say, in a chemical reaction, when the energy of colliding reactant particles is less than the activation energy, when the energy of the colliding particle is less than the activation energy, the reaction will A, they say, be spontaneous. B, they say not occur. C, they say occur. D, be slow. Okay, when we say the activation energy is the energy barrier that must be overcome by colliding particles, okay, before they can form a product. It means that if the energy generated by the colliding particles is less than the activation energy, that reaction will not occur. So that's why our correct answer there will be option B. All right, so now let's look at another question, a 2013 question number 28. They say the minimum amount of energy required for a reaction to take place is, that will be activation energy. There's nothing to brood about there. All right. So these and many more questions are on this application. Please download the app, activate it, and start studying. Okay, start studying like your life depends on it. Like this video, subscribe, and keep sharing. And I'll see you in the next episode. Thank you for watching.